Hi everyone, welcome to my channel. My name is Fikret. This video is part of series on Apache Spark Essentials for Data Engineers. In this video, we're gonna explore column level transformations in PySpark. Let's explore some transformations. The first transformations type we're going to explore, column transformations. So in command 29, I demonstrate how to narrow down list of columns coming from source. And I use select method for that. The select method requires a list of columns that you want to bring, and optionally you can apply certain SQL functions on some of the columns. So for example, here I use call function, which is one of the native SQL functions to bring sales amount column values. And then I use alias method to rename this column. There are lots of helpful SQL functions that you can use as expressions, and we'll explore some of this a little later. But whenever you are using SQL functions, make sure that you are importing them like this. Select transformation works like select list. And if you are familiar with SQL, you know that with select list, you can either bring columns as is or apply certain functions or transformation on them. The alternative way of narrowing down columns from data frame is select method, and it works similar way to select method, but you can see that its syntax is slightly different. So here, for example, I use as expression to indicate aliases for columns, and I can use SQL functions direct within column definition. For example, the cast function that you can see here is one of the common ways to change data type. So this expression takes price column and converts its data type to decimal. Similarly, I use round function here to round down results of mathematical expression. So in this case, I calculate tax amount by multiplying sales amount to a certain value. Here is another useful function. So this expression, metadata file name, allows you to bring file name as metadata to your data frame. So this is often useful to provide data lineage. So let's take a look at the output. So here I have source file name, and here we have tax amount I have calculated. Another way of narrowing down column list from your data frame is to use drop function. Drop function, as the name implies, simply drops the list of columns that you provide in the argument from your data frame. So for example, here I dropped client name column from my data frame. The column level transformations that I have demonstrated earlier, they are imitating SQL syntax in one way or another. However, there are some methods which allow you to add calculated columns which have little different syntax in PySpark. So here in command 34, I use a withColumn method to add calculated columns to my data frame. withColumn requires two arguments. The first one is to indicate the resulting column name, whereas the second argument will represent the expressions that you use to get this column. You can use SQL functions that we have seen examples of as part of your expression. So in this case, I am using round function to round down results of multiplication of sales amount. Notice that I am referring to sales amount column through data frame dot column name notation, just like this. But there are some other ways of referring to your column values from within withColumn method. So for example, here I am using call function, which we already discussed, to get sales amount, and then I apply cast data type transformations on top of that. Another useful SQL function is lead function. It allows to attach a fixed string to all of your rows. So for example, here I want to add this string, fixed string, to all my rows. This could often be useful to provide data source names or any useful metadata that you want to include in your data results. Another useful SQL function that's worth of discussion is monotonical increasing ID function. It allows you to generate sequential numbers, which can be used to generate identity columns. So in this example, I use it to generate row ID column with sequential numbers. When building your transformation, you often need conditional type of expressions. And one of the common transformations in that category is if-else type of transformations. So the when function that I have provided as a last transformation in this data frame is conditional. It checks for product name column for certain fixed value. And if product name equals to bad, then it will produce one value. Otherwise, it will produce another value. Of course, you can use more complicated version of this expression with multiple chains. Here I just brought a simple example. I'd like to wrap up column level transformation topic with another demo which explains how you can parse semi-structured data. Earlier, we have ingested product information, and one of the columns this table had was complex type. So we had sub-column names here on the category column. So let's see how we can easily extract different parts of this column using SQL expressions. The command 36 extracts furniture type and the room type from category column, and to do that I can use columns names dot subpart. That's it for column transformations. I hope it was helpful. Thanks for watching, and I'll see you in the next part.